Hello, everybody. Welcome to today's edition of Dementia Talks Canada. My name is Leah Sandals. I'm senior editor at the Alzheimer's Society of Canada and the moderator for today's conversation. Uh, this talk about biomarkers in dementia is presented by Alzheimer's Society of Canada in partnership with Brain Canada. You can find out more about both of these organizations in the chat. Before I jump into welcoming our panelists, just need to go over a few housekeeping items. This session is being offered in English as well as in French. To select a language, you can click on the interpretation button at the bottom of your screen and then choose the language you want. You will also notice that poll questions have or will occasionally pop up on your screen. The answers help us understand if we're meeting your needs, so please do provide your feedback. This talk is being recorded and will be available in the days to come on our YouTube channel, as well as on our website, alzheimer.ca. And anybody who's registered for the webinar will get a little alert about that when the video is available. You'll get a ping on email. Lastly, this is a conversation. The chat is open and is being moderated for conversation. Feel free to share your lived experience, any evidence-based tools or resources, or just introduce yourself if you'd like. If you have questions for our panel, though, please add those to the Q&A box, the specific Q&A box that if you're on a desktop is at the bottom of your screen. You can click on that, add the question, and we will try to address it at the end of our session. Also, just a word, if we don't manage to answer all the questions live here in our hour together, we will follow up by email after the session to make sure your question gets answered as long as you have submitted it with your name attached. So I'm coming to you today from land that is the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples, and is now home to many diverse First Nations, Inuit, and Métis peoples. I also acknowledge that Toronto, where I live and work, is covered by Treaty 13 with the Mississaugas of the Credit. We at the Alzheimer's Society encourage you to learn more about Indigenous-led and Indigenous co-led initiatives in dementia, which are growing. These include, but are not limited to, the Native Women's Association of Canada's resources about aging and dementia, the website of Anishinaabe Dementia Care, the Canadian Indigenous Cognitive Assessment, which is a special kind of cognitive assessment that is culturally appropriate to Indigenous folks, more so than the widely used cognitive assessments that are out there. And there's also dementia resources available from the National Collaborating Center for Indigenous Health, just to name a few options. The websites of these groups and organizations are now in our Zoom chat for you to please use, share, support, and learn from. It's now my pleasure as well to just do a brief slide presentation to introduce this topic of biomarkers in dementia, since it can be a bit technical at times. And then we'll get into our group discussion with some researchers doing amazing emerging work in this area. So I'm going to ask for the next slide, please. So what is a biomarker? It's just, in terms of a word, it's a shorter way of saying biological marker. And biomarkers are features of the body that we can measure. Next slide, please. So in terms of like biomarkers in general, before we get into the topic of biomarkers and dementia, biomarkers is a kind of a newish word, but as a concept, it's existed for a long time. You know, when we go see healthcare providers or even measure ourselves, these are some common health biomarkers that you may already be quite familiar with. So things like blood pressure, heart rate, blood glucose or blood sugar levels, cholesterol levels, bone mineral density. Those are just a few examples of things that healthcare professionals can measure in our bodies that can then give us some helpful information about our health. Next slide, please. So some key facts again about biomarkers in general. Okay, so biomarkers are things again that can be measured, and they can be measured accurately and reproducibly. So they're consistent things. It can be measured consistently. Biomarkers can help measure the presence or progress of a disease or the effects of a treatment. So going to the blood pressure example, let's say I'm detected to have high blood pressure, then I'm put on some treatment medication for that. Well, the biomarker blood pressure measurement can also be used after I take the drug or after I start taking the drugs to see if it's having a helpful effect in lowering my blood pressure. Biomarkers can be molecular, they can be imaging based like x-rays or scans, they can be cell based and more. So those are some key facts. Next slide, please. A few points about what biomarkers are not. Okay, so biomarkers do not define how a person feels or functions. For instance, again with the blood pressure example, someone can have high blood pressure and not know it until informed by a healthcare professional following a blood pressure test or after doing a blood pressure test themselves, maybe at the drugstore. Lots of drugstores have those, or at home. Again, biomarkers, and there's another way of saying it, is that biomarkers are not clinical symptoms. So researchers and scientists and doctors, professionals sometimes like to use this term clinical symptoms or medical symptoms. Those are the signs of health or illness as perceived by patients themselves. So again, to use the blood pressure example, let's say I'm having headaches or I have dizziness. Those can be clinical symptoms or medical symptoms that I might experience of high blood pressure. Then I might go to my doctor or healthcare provider, and perhaps a blood pressure test bears out that it could be, yes, I do have high blood pressure as a biomarker measurement, and perhaps that's the cause. So that's the distinction between what are called clinical medical symptoms and biomarkers. The biomarker is externally measurable. The clinical or medical systems are something that I would self-report as my experience. And important, a potential biomarker is not meaningful necessarily until it's proven to be so. So we can measure so many things about the body and like even just substances in the blood, right? But it takes research to show how something we can measure in the body relates to issues of health, illness, or disease. Next slide, please. And so what about dementia biomarkers? Well, before the early 2000s, there weren't many biomarkers that were known for most dementias, including the most common form of dementia, Alzheimer's disease. Back then, the main way to know what kind of dementia somebody had had in their lifetime was by doing an autopsy. This was the case in my family. My mom had dementia in the 90s, and doctors made their best guess as to what kind of dementia it was, because there's like more than 50 types of dementia, and conditions related to dementia. There's a wide variety. So, but the only way they knew what kind she had, which ended up being frontotemporal dementia, was after she passed and they did an autopsy. But now there's more options. Next slide, please. So now there can be biomarkers used in dementia diagnosis in Canada. Now, 20 years after that, we're past those early 2000s. Some biomarker measurements that are commonly used are brain imaging. So like CT scans, MRI scans, and PET scans. Those can help doctors see whether clinical symptoms like, let's say, thinking issues or movement issues or vision issues could be related to things like a stroke or a tumor or fluids in the brain that they could see on a scan. Scans can also show like brain shrinkage that some dementias could cause. And they can also show things like amyloid beta, tau, or fluorodeoxyglucose, which are some substances that many researchers believe could be related to different forms of dementia. There's also testing available in Canada. Specialists have access to testing for cerebrospinal fluid, which is a long way of saying fluid around the brain and the spine. So that fluid can be extracted from the body and tested to find proteins that, again, many researchers believe relate to Alzheimer's disease, like amyloid beta protein and tau protein. Now, testing and collecting that fluid requires a lumbar puncture, which is a puncture at the base of your spine. It's a pretty specialized procedure, and it can be expensive for the healthcare system to do. Similarly with brain imaging, as you may already know, the equipment to do brain imaging is sometimes not available a lot of the time in all communities, or if it is, it's being run around the clock, and it takes a while to get an appointment. Next slide, please. So that's part of the reason we're looking for more biomarkers. Coming up, sometimes genetic testing is another biomarker test that can be used in screening or diagnosis for some dementias that tend to run in families. That's not necessarily always the case. They tend to be rarer dementias, but it can be helpful in those cases. Next slide, please. So What's next? Well, this is what we're here to talk about, developing other kinds of biomarker testing beyond this very expensive and kind of medically involved spinal fluid puncture method and beyond the expensive and somewhat inaccessible brain scanning method could make dementia diagnosis cheaper, quicker, easier, and more accessible. So we're talking about blood testing, saliva testing, tear testing, and more. Let's talk about that now with our emerging researchers. Thank you all for your patience with that as we get started. So with that presentation. So now it's my pleasure to introduce the panelists today, all of whom provide important perspective on this issue. All of our speakers today have recently received awards and grants from the Alzheimer Society Research Program. To find out more about this program, which distributed nearly 6 million this year to 44 dementia researchers, including many awards in collaboration with Brain Canada and other partners, please visit the link that's been shared in the chat. First, let me welcome Michael Adachi, an assistant professor in the School of Engineering at Simon Fraser University. Michael is working on developing a simple, low-cost screening tool that could detect multiple Alzheimer's disease biomarkers. And his Alzheimer's Society Research Program Award is co-funded by Brain Canada Foundation. Welcome, Michael. Thank you for being here. Next, we have to introduce Jennifer Cooper, a PhD candidate at the University of British Columbia, Department of Pathology and Laboratory Medicine. And Jennifer is researching blood-based biomarkers of neurodegeneration or brain degeneration. Thanks for being here today, Jennifer. Lovely to see you. And finally, we welcome Printha Wijasinghe, a postdoctoral fellow and trainee in the Department of Ophthalmology and Visual Sciences in the Faculty of Medicine at the University of British Columbia. Printha is researching something really interesting, which is tear-based and eye-based biomarkers for Alzheimer's disease. So thank you all so much for joining us and taking time out of your important research to chat with us today. So let's begin. My first question is, what do you wish more people in Canada knew about this topic of biomarkers and dementia? I think I'll ask Jennifer to answer first, please.
All right, thanks, Leah, for the introduction. And thanks also for kind of giving a really good background on how biomarkers can really help us move towards a more biological diagnosis as opposed to a diagnosis that's based on symptomology. So one of the things that I think people should know is that biological diagnosis is something that's going to be necessary as more different treatments come out into the world that are disease-modifying therapies. So for example, in Alzheimer's, there are disease-modifying therapies that are coming out that can remove amyloid or tau from the brain, but we need to actually know for sure that those biological features are there, and that can't necessarily be picked up by something like a cognitive test. So it's an analogy I like is it's kind of like when you go to a doctor and you have a sore throat, and you're like, give me some antibiotics. And they say, well, I'm not going to give you antibiotics unless I know you have bacteria in your throat. So it's the same kind of principle there. So that's why we really need to start moving towards this biological based diagnosis, and biomarkers are a great way to do that. However, what we do need is things that are more accessible to the public and maybe a little bit cheaper for the healthcare system. So my work is focused on blood-based biomarkers, which means essentially you would be able to go to somewhere like Life Labs and get a blood test, and that would be a tool that you could use to diagnose Alzheimer's or other forms of dementia. And I think one thing that I'd really like people to know about this research is that it's not something that's years and years and years down the road. It's something that is at the forefront of this field. It's something that researchers are very excited about. In Canada, it's not available yet, and it's not widely available in other places in the world, but it is starting to appear. So in places like the United States or in some European countries like Sweden, there are blood tests for Alzheimer's that are starting to become available. So this is something that in Canada, I really think we should be moving forward with, and something that could be available in hopefully the coming years.
That's really great. I appreciate your analogy of to the sore throat and how biomarkers can be useful. So what you're saying, just to recap that, is that just like if we have a sore throat, go to the doctor, they won't give us the treatment that's available, antibiotics, unless they do the swab and find the bacteria in there. with dementia, it could be like, I'm having thinking issues, movement issues, personality issues, go to my doctor. And if they're able to do an easy, not a swab exactly, but a blood test, let's say, that shows dementia biomarkers, there are 4 treatments already available in Canada for managing symptoms of Alzheimer's disease. Then somebody could start on those if those are Alzheimer's disease biomarkers. Right. Okay,
Exactly.
cool. Thank you for that. And Michael, you come at this from a slightly different perspective than some of our other researchers as an engineer. What do you wish more people in Canada knew about this topic of biomarkers and dementia?
Oh, yes. Well, first of all, thanks for having me on this panel and that really nice introduction to biomarkers. One thing I'd like, one thing I'd like to more people to know is that there's a lot of exciting research going on around the world on biomarkers and dementia. And what people have found, or researchers have found that is that the protein misfolding that happens in the brain of, say, Alzheimer's disease patients can happen over 10 years before the clinical symptoms are noticed. So some of these biomarker proteins, either found in the blood or other biofluids, can actually help doctors diagnose Alzheimer's disease, but also be used as predictors to see if maybe someone's at risk of developing Alzheimer's disease. And that could give, I guess, people the opportunity potentially to introduce treatments at an earlier stage, and also start lifestyle changes that might also help promote brain health. Yeah, so another potential application, I guess, for biomarkers is to help identify what kind of dementia a patient might have. I know personally, my dad had dementia, but we never found out what type of dementia he had. So I think looking back, it would have been really nice to know, I guess, more information. It was at that time, it was kind of like a very general diagnosis of dementia, but I think it would be really helpful to know what type it was, and biomarkers could help us, I guess, differentiate certain dementia from another.
Mhm. Yeah, thanks for sharing that, Michael. Yeah, I find, especially now, there's so many great specialty support groups online or advocacy groups. Like, let's say, since working here at the Alzheimer's Society, I've learned that, there's specialty groups for post-cortical atrophy, which is a kind of dementia, right? Or um, supranuclear palsy, as well as for frontotemporal dementia, the kind that runs in my family, right? So there can be a lot of even in the absence of treatments, there can be a lot of benefit to at least being able to connect with people who are going through something similar, and to do advocacy and all that kind of stuff. That's my opinion, but thank you for speaking to that. Printha, I know you have a lot of insight here too. So what do you wish more people in Canada knew about biomarkers and dementia?
First of all, thank you, Leah, for this opportunity, and Alzheimer's Society Canada and Brain Canada. I want to highlight the same thing almost. I wish first the more Canadians knew that there are many different forms of dementia. For example, 60 to 70% Alzheimer's disease, but there are other forms are there: vascular dementia, Lewy body dementia, frontotemporal dementia. So, and also I wish more people in Canada knew that there are different biomarkers, possibly for different kinds of dementia. For example, for Alzheimer's dementia, cerebrospinal fluid amyloid beta 42, low level 42, and elevated tau, phosphorylated tau level, and also brain atrophy in MRI, something like we have different biomarkers. I also hope that more people in Canada knew that it often takes a combination of tests, in addition to clinical assessment, like spinal fluid biomarkers or PET imaging, are currently used to diagnose dementia. For example, for Alzheimer's disease, I said, in addition to clinical assessment, we use CSF or cerebrospinal fluid biomarkers and PET imaging. But these procedures are actually highly invasive and expensive. So I think, therefore, there is a need to find, develop easier cheaper and faster test. If you could, if you identify early, you could take possibly, potential action against it. So that's what I want to highlight here about this for the first question. Thank you.
Yeah, thank you, Printha. That's a great point. Like you all are researchers, so you know in depth how many kinds of biomarkers there are, how many kinds of dementia there are. It's just a huge, huge field. So thank you for highlighting that. And yeah, thank you for highlighting some of the benefits of getting an early diagnosis. There really are so many at this point. So thank you for that insight. Now, do you have any other, do any of you have other thoughts to share? We also have a second question we can move on to, but I just want to check. Yeah, I think we should go to our second question because there's a lot to delve into, but always feel free to share thoughts in the chat as well. So what do you hope, the second question is, what do you hope to find out or be more certain about on biomarkers and dementia when your Alzheimer's Society research program funded project is complete? Michael, maybe if you could answer first, please.
Sure, yes. So currently it's really difficult to access biomarker tests for Alzheimer's disease or dementia, as Jennifer had mentioned. But like in the US, several companies are actually starting commercial blood tests. So they'll actually look for certain biomarkers like amyloid beta and some of the genes associated with Alzheimer's disease. But the typical costs are actually quite expensive still, something like $500 to $1,200 US. And there's at least one company in Canada that's starting this work as well. But I guess one of the drawbacks is it's a very expensive measurement to run. The commercial blood tests are commonly performed using a method called liquid chromatography mass spectroscopy. Really long word, but it requires a very expensive piece of equipment, and samples have to be shipped to a centralized lab for testing, and throughput can be limited just because I guess the equipment is so expensive. I guess research-wise, what we're looking at is we're trying to develop a simpler way to detect these biomarkers at really low concentrations so that we can detect them in blood samples, possibly other biofluids. And we're using nanotechnology and electronic sensors to try to make a more simple, rapid, and easy to use sensor for detecting some of these biomarkers.
Great. So yeah, really you're working on like developing equipment that'll maybe be less expensive or difficult to run than these mass spectroscopy machines.
Exactly, yeah.
Okay, and that would eventually, yeah, increase accessibility and reduce the cost. Awesome. Printa, what are your thoughts? I did appreciate your point earlier too, that diagnosis is always a multi-assessment kind of thing for dementia. It's not just one, not one test is going to be a silver bullet per se, but there are always multiple tests. I know you have a slide actually for helping us answer this question about your research. So I'll just ask our tech team. Please put up the slide for Printa's. Okay, so Printa, can you tell us more about your research and what you're hoping it brings and what you hope to know more about?
Thank you. So, well, I'm actually looking for non-invasive biomarkers or less invasive biomarkers based on the fact that eye and brain share common origin. So they are closely connected. So actually scientists are already working on non-invasive retinal biomarkers using advanced imaging techniques to locate harmful protein deposits, example, beta amyloid deposits in the eye, in live animal models. But how early and how clearly they can detect these changes is, we need to work a lot on this part. So what I am doing is looking at the underlying molecular level changes called microRNAs, how they play with these harmful protein production. So I use actually animal models at this time, using the brain tissue, eye tissue, and the tear samples at different time points to see how these molecular markers changing over the time. So these microRNAs are actually small piece of genetic materials, and they're found abundantly in our body or in our cells. So they don't make proteins actually. Actually, they regulate or control the gene expression and thereby control the protein production. So these microRNAs usually can be secreted outside, and they're highly stable in the outside environment or in the body fluids. There are several studies actually have found normally these microRNA levels changes with human disease conditions or pathological conditions. And those studies also said, these microRNA has potential, translational potential as potential biomarkers for different disease conditions. So actually, there are a lot of studies on microRNA investigation in Alzheimer's disease, postmortem samples, CSF samples, and mostly on blood samples. But, we have to find the early biomarkers. So when we consider blood actually, is a body fluid for the all our body fluid. It's not specific to central nervous system or eye. So what I'm looking is actually eye is most closely connected to the brain. So if I prove through my study that what is happening in the brain is also happening in the eye, and you can see in the tear fluids those changes, then I can use these tear fluid microRNAs as biomarkers for my for the future, for human testing, so human trials. I also want to point out here, tear fluid samples is actually easy to collect. Okay, you just need a tear test strip. You don't need any, in very invasive procedure or anything. And you don't need to process also. You just take these tear fluids using the tear test by keeping it in the bottom of the eye. And then you just put it in a nucleus-free water and store immediately in -80, or just transport in dry ice and in -80 until you process. And you can use this as the starting material. So actually, I did a preliminary study in an Alzheimer's disease animal model by investigating these three tissues: eye tissue, brain tissue, and tear fluids, and I found a relationship. So now in this Alzheimer research program, actually I'm using another model which express both pathologies, amyloid beta pathology, tau pathology, and also inflammation, neurodegeneration, all kind of things associated with this Alzheimer's disease. And I'm checking at different time points to see how it, and also male, female mice. In my preliminary study, I just only want grow female mice only. So my ultimate point is to, how we can use these tear fluid biomarkers to test in human for early diagnosis.
Amazing. That's so great. Yeah, I thank you for explaining that. You can probably take the slide down, Dave, but I just, when we talked earlier about this topic last week, I learned so much because I thought testing tears means means you need to cry to get the sample, but you very helpfully explained that actually you just pull down the eye and like stick a test strip in there, and then like you said, put the test strip in a tube, and it's much easier to transport and process. It's more stable than, let's say, a blood sample would be. Yeah, that was really eye-opening for me too, where you pointed out that blood is a fluid that runs through the whole body. It's going to pick up materials through your whole body, whereas the eye is actually very connected to the brain. So it's going to be more possibly better. Possibly you're trying to find out a strong index of what's happening to brain cells and proteins in there in possible dementias. Did I get that right? Is that right-ish? Okay. Thanks, Printha. Yeah, it's really great research. Really, really fascinating, and could really be so accessible because it would be just those tiny test strips, not even a needle needed. So, and some dry ice. So very cool. Jennifer, can you tell us more about what you're looking at? please?
Yeah, for sure. So I'll also kind of build off of what the other speakers have talked about. I know, Prince, you were just talking about how blood circulates through the whole body and can, not be as specific to the brain. And that is true. And it's true of a lot of markers. But I do want to also mention that what a lot of the research is focused on is trying to find markers that are specific to the brain, that have their proteins that have been modified in the brain specifically. So when we do detect those, we can say that they're a little bit more brain specific than other things. So that's just something to note and be aware of. And then also just kind of building off of what Michael was talking about with having kind of more accessible, easy to use platforms. Another methodology with that, like, it's very interesting and exciting to hear about new technologies that we can use that are maybe more point of care devices that are easily accessible in remote areas. But another thing we're really trying to do with blood tests is move towards using analyzers that are already accessible at, say, a hospital site or a testing facility that, say, your doctor would send you to get a blood sample done at. So what my research is really focused on is kind of trying to move us from the point where we have a blood biomarker that we say, okay, this is a marker that looks different in someone who has Alzheimer's or maybe another form of dementia, and kind of making those final steps to make it able to be implemented clinically. So one thing that a lot of people don't necessarily know is that there's a lot that happens in between saying, we have a blood test for Alzheimer's, and actually being able to put it into clinical use. So we really need to have a deep understanding of what these biomarkers look like in a whole bunch of different scenarios. I mean, one of the things we've talked about is that we want to have biomarkers that can tell apart the different types of dementia. So if you measure this blood test, are you going to be able to say for sure that person has Alzheimer's and not frontal temporal lobe dementia? So that's one of the things we're working on. And then also kind of trying to find out more about these biomarkers in healthy people so we can make specific cutoffs for these markers. So when you go and get a blood test, typically you get a sheet back from your doctor that will say this was your level, and then next to it it'll have the range of what is normal. So it'll be maybe based on your age, your sex, and that's kind of telling you what is normal and whether your level falls into that. So one of the things we're working on is really trying to define those normal levels and different things such as age or sex that can alter these biomarker levels so that we can really have the best interpretation possible. And it's one of the major steps in really making these biomarkers implementable in widespread clinical use.
That's great. I'm so glad you're working on that, Jennifer, and all of you in your research. Yeah, it really helped me understand when you talked about the cut points, because I know if I go to, like you said, get a blood test for like a thyroid level or something, and it goes back to my doctor, there's those sense of like you said, here's the normal level, here's the high cut point, here's the low cut point, and that's part of what you're trying to figure out would be for amyloid or other Alzheimer's disease biomarkers, right? Because it takes research to figure out what is the normal range based on your age and when is it an issue? Yeah, thank you for that. Well, about testing availability and access, I know you all have great additional insights as well. I mean, my last question is around what do you think, from where you sit, what do you think governments or healthcare organizations or agencies in Canada should do next about biomarkers and dementia? Printha, I was wondering if you could answer first, please.
Yeah. So I think actually government should support, actually in the meantime, some cheap and biomarker means of improving dementia diagnosis. For example, I think, that starting at 55, everyone in Canada should be given some brief annual cognitive exams with their regular physicals with their family doctors, so that, a baseline is established for their cognitive levels and memory, thinking, or those abilities. For example, actually there is something called mini mental state exam. So it just takes few minutes to complete. So then, if they do annually and then if they track, so they can actually very early, they can identify, who has some kind of memory loss or singing inabilities or something they cannot do their day-to-day activities or something they can find. So this will actually help people to plan earlier, take the actions immediately to slow down the progression, and in their workspace or, disability accommodation or something like so. They can prevent or they can protect early. So I think that's what I would recommend. Thank you.
Thanks, Printa. Yeah, I appreciate that even though you work on biomarker research, one of your main recommendations is like, well, we don't need to just focus on biomarker implementation. Like there are things we could do, like these mini mental state exams every year in an annual physical starting at age 55, that if done every year could then help doctors flag if there's a possible dementia issue earlier than happens now. So I love that. Thanks so much, Printa. Let's see here. Jennifer, what are your thoughts about what you'd like to see next? You already mentioned a little bit about the need for implementation, how long that takes.
Yeah, and I think along those lines, I mean, the question of what should governments do next is such a big question, because there are so many things that really we should be doing to kind of start implementing things. So I think really my answer is we should start to create a roadmap for implementation. I think governments should really be starting to work with researchers and kind of find out what are the next steps for implementation, and kind of, make sure that there are avenues for the research to be translated, and make sure that people are ready for things to come into place. I think it would be really useful for the government to kind of work with researchers to kind of create, a stepwise program for how we start to do this. And there's definitely other places that we can look to kind of get guidance on this. As I said, there are other countries that have started to implement blood biomarkers. So we can look to see, what did they do? How are they kind of starting to do this? We need to answer a lot of questions about, how we actually implement these biomarkers in terms of, is it a diagnostic tool? Is it a screening tool to predict if someone's going to have some type of dementia? We really need to kind of work together to figure out what the best path forward is. So it's not so much one thing that the government should do, but really just working with researchers to figure out all the steps together, instead of kind of doing one thing and then stepping away from the table and coming back years later to figure out the next thing.
Yeah, that's a good point. There's so many things around administration and development that are just huge and require kind of multi-group actions to make happen. I think, Michael, you have some insights into that as well from like an engineering development lens.
Yes, thank you. Yeah, so I guess to make an impact on society, the research results really have to be translated from a lab to commercialization. So it'd be really great if I guess the government or healthcare systems can help with this translation. And one of the, very expensive and time-consuming challenges that companies face is obtaining regulatory approvals to, use their devices in commercially. That can be really prohibitive for a lot of companies, especially if they're very small companies that don't have that those resources. So I think it'd be helpful for more support for bringing these technologies to commercialization.
Yeah, I think when we talked earlier last week, and similar to what you said, Jennifer, there's a huge cost in bringing even not just drugs, but bringing assessment tools to market. So even if it's not an invasive thing, obviously with drugs, it's very important to make sure anything we ingest is safe and effective before it proceeds. But it was learning for me to know, like, oh, it still needs to go through quite an extensive tool assessment process, like a measurement tool assessment process. So that's really helpful to know. Thank you all so much. If is there anything else you'd like to say before we start our Q&A? No, I see there's a great discussion in the chat about in French about thank you, Julie and Andre, for talking about different perspectives on whether early diagnosis is helpful or not. yeah, it's a really important question. And I think from my perspective, I'll just say that as somebody who lived at risk of a certain kind of dementia for quite some time, the main thing I'd like to see, and I know we're sharing some personal perspectives here too, is that people at least have the choice to find out about whether they have dementia and what type of dementia they have without going through a like multi-year process. To me, it's about choice. But that's a great conversation in the chat. Keep it up. I appreciate everybody's respect for each other there. But yeah, we can go into the Q&A now. All right. So I see there's some very specific questions here, and there's some that are a bit more general. I'll start with Joanne Papineau. And Joanne, if we can't answer this here live, we will follow up with you about it later. So do any of your panelists want to comment on whether the SIN1 test is available in Canada? Are any of you aware of that at the moment? No, okay, so that's not your area of specialty. Okay, so Joanne, I will follow up with our team at Alzheimer's Society of Canada, Joanne Papineau, and we will email you after this session. It's a great question, so thank you for bringing it up. Rebecca Atkinson has our next question. So it again relates to some of the things you were talking about, everybody. What's needed to make this accessible to Canadians? I'm hearing cost is a barrier, but what else is a barrier? Good question. So who would like to answer that first?
I think I can answer that. I think there's quite a few complex barriers going on here. I mean, we did talk about cost, but also the fact that the pathway through government regulation is not an easy one. It's a multi-step process. A lot of things need to be done both at the federal and provincial level to get these tests approved. And I think also public opinion does come into this a lot. I mean, as Leah was saying in the chat, there's probably a lot going back and forth about whether early diagnosis is a good thing. And I do hear a lot of people say, well, why would you diagnose me early if there's no treatment that can cure me? But I think it's important that we also start to get these, different types of biomarker tests approved before we actually have those treatments that are widely available. Because if we wait until we have treatments to start working on early testing, then we're just pushing back even further to when we'll be able to properly implement this. So we really need to kind of have everything going tangentially at the same time, but it is kind of a barrier to getting these tests approved and widely available, that there is that kind of public opinion of, well, I don't want this test if you can't treat it. So
Yeah, that's a good point. Thanks, Jennifer. Anybody else about this question of access? What are barriers to diagnosis access beyond cost? I have some thoughts on this from a knowledge translation perspective, but Michael and Printa, is there anything you'd like to say?
I think they should know first, this memory loss, and these are normal part of aging, first of all. So, if they're aware about it first, then, they take actions really. Canadians, okay. If they think that is a normal part of aging, and then, later on, if they go for the treatment or anything, then, they can't prevent the progression or anything. So I think that's my point here.
Yeah. Thanks, Printa. Yeah, there are things everyone can do to reduce their risk of dementia, their relative risk. We have information at alzheimer.ca, reduce your risk, which I'll put in the chat. And those are some actions people can take. So for example, yeah, if you find out you're maybe in a hypothetical situation, maybe you have higher biomarker risk for dementia, steps one could take is actually to socialize more often. Social isolation is a changeable risk factor for dementia that I love to highlight. Make sure if you have hearing loss, get a hearing aid. That's a huge, huge one. Get a hearing aid that works for you. Yeah, there's more in that link I shared, the alzheimer.ca. Oh, I did a misspelling. Apologies. Thank you, Dave, and production for resharing. Michael, any thoughts on what else is a barrier in terms of accessible biomarker diagnosis?
Yeah, I think another barrier, I guess, is like the need, I guess, for more research relating biomarkers to Alzheimer's disease and other dementias. I think, at least for Alzheimer's disease, there are promising, I would say, biomarkers that um, that can be used for early diagnosis, but at the same time, there's no like single biomarker that's kind of like the silver bullet. Like there's evidence suggesting that some of these biomarkers can help predict whether someone will develop Alzheimer's disease, but at the same time, there's no widely accepted biomarker yet. So, like more research is needed to identify and learn more about these biomarkers that I guess that people are interested in, but maybe even biomarkers people haven't even considered yet as well.
Yeah, those are great. Yeah, I think other ones that I'm aware of in terms of accessible diagnosis and like existing accessible biomarker diagnosis, Rebecca, just to finish up on your question, um, is even things like CTs, MRIs, and PET scans, which are biomarker measurement methods already in use in dementia diagnosis. I mean, those are mostly located in larger hospitals and facilities. They're very expensive machines, so that's a cost, but it's also a barrier for people who live in remote and rural locations that are far away from those MRI machines. So if there was a simpler test that could be transported more easily, then that's another barrier, the barrier of distance. And then generally, I think also, as we know, our healthcare system generally is under strain right now. Um, and often getting a dementia diagnosis right now, even with these specialized biomarker tests that do exist, requires access to a dementia specialist. For example, Impact AD, which is a research center in BC that's doing fantastic work they offer spinal fluid testing for dementia specialist physicians across Canada. Fantastic. That's great. But there's a limited number of dementia specialist physicians in Canada. So if we could get a test that general physicians could also use or other healthcare workers that could be proven, all that, that would improve access because we know that people are even having problems accessing family doctors, right? Let alone dementia specialists. So that's just my perspective from some of the questions we field at ASC, Alzheimer's Society. Thank you, everybody. So Mario, yay, Mario's here. Mario's an amazing member of the advisory group and so many other dementia research initiatives nationally. Thanks for being here, Mario, and making time. Please clarify the medications, Mario's asking, as a help in daily living instead of preventative medication. Most of the new drugs are aimed at people with Alzheimer's, not other dementia. Okay, thanks. That's more of a comment. Thank you, Mario. Yeah, that's a really great point. So what I'm hearing, Mario, is it's important for us to emphasize that the current medications that are available for Alzheimer's disease, so those 4 medications that are approved for Alzheimer's disease, are a help in daily living. They're not preventative. And most of the new drugs that are in development, good point, are aimed at people with Alzheimer's, not other kinds of dementia. I can say though, Mario, that in my personal experience, again, sorry I bring this so much to these conversations, but as like a person with some lived experience, one of my cousins is in a research study for frontotemporal dementia right now for a particular frontotemporal dementia treatment because of the genetic biomarkers that she has. So the genetic biomarker that she has permitted her to at least participate in development of those new drugs, which is something she wants to do. Other people may not want to do it, but that's where we're at with that. But sorry, I've taken that over. Anybody else want to respond to this question of like where the medications are at now and how they could be helpful at an early stage, even if they're not preventative?
Yeah, so I think a lot of the medications, this is definitely not my field of research, but from my general understanding is that a lot of the medications that are being developed are meant to target a specific pathology. So I think it's a little bit tough to kind of combine the two in the fact that a lot of times when we talk about Alzheimer's disease, we consider it like Alzheimer's disease dementia. But then when we're talking about the actual disease modifying therapies that are coming out, they're targeting like one specific component of that. So they're targeting, say, amyloid plaques, and that's what they're trying to remove from the brain. So I don't know a ton about other forms of dementia, but there are other pathologies that underlie those forms of dementia. So it would be different types of targets that those drugs would be looking for. I don't know what the progress of those are, but I know in the Alzheimer's field, there are a lot of drugs that are in kind of that phase 3 clinical trials near the end of the process that do target both amyloid and tau pathology.
Thank you, Jennifer. Anybody else want to take on Mario's cogent comment or concern about the way we frame medications? I think you made it fairly clear in your comment, Mario. It's a great point. So thank you. There's more I need to learn about this for sure. And thank you, Jennifer, for offering your perspective as well. We still got a couple minutes left, so and lots of questions again. Those who have submitted anonymously, just so you know, it's difficult for us to follow up by email after if you submit a question anonymously. You can also email us at publications@alzheimer.ca with your question if you want to remain anonymous. So I'll just drop that in the chat. And we will try this question last. Is there any difference, great question, any difference between biomarkers of Alzheimer's between men and women?
I think I don't think there is a difference in biomarkers between men and women, but women, they are vulnerable to this condition early. They are kind of considered as, as a risk factor woman, but we can't help. But I don't think there is any change in normally, CSF levels or the brain atrophy. Those biomarkers is same between male and female, from my understanding.
Thank you, Printha. So you're in the research you're seeing, you're not seeing so much of a difference in biomarkers for Alzheimer's between men and women. That's helpful. Michael,
yeah,
Jennifer, any thoughts on that in the current research that you've seen?
Yeah, I mean, I think really it's not so much biomarkers in general, but it comes down to the specific biomarker. So every biomarker is going to be different in terms of whether you see sex differences or not. I know with the specific blood biomarkers I work with, we don't tend to see any sex specific differences. So when we're making those cutoffs that I talked about developing, it's not a different cutoff for men and women.
So you're not seeing a difference there. There are differences between women and men in dementia, just generally symptoms and stuff, clinical medical symptoms, sometimes there's differences. Michael, do you have anything else to add before we wrap up here?
No, I agree with the previous comments.
Okay, great. There's a poll question on the screen there. I'm going to try and squeeze this last anonymous one in case this person can't email us directly. Can dementia with Lewy bodies be differentiated as a diagnosis when compared with Alzheimer's using the current biomarkers technology?
I think that's a great question, and it's definitely one of the issues that we run into. Is this kind of comes back to what I was saying about the different pathologies that underlie the disease. And you can be someone who's been diagnosed with Lewy body dementia, but you may also have co-pathology of another dementia, meaning your main dementia form is Lewy body dementia, but you may still have those amyloid plaques that appear in Alzheimer's, which is really one of the things we're trying to unpack and untangle right now into how we kind of, pull those things apart, or whether we should just be saying, well, you have amyloid pathology, so that's what we should treat. You also have the pathology for Lewy body dementia, and we should also treat that. So there are biomarkers that can hopefully tell these things apart, but co-pathologies of different types of dementias cause large problems here.
Good point. Is there anything else? We may need to wrap up. Anything else, Michael or Printha, quickly to add about that Lewy body question?
I think that maybe that in this brain imaging or something, Lewy body dementia, mainly the main form Parkinson disease and these things, you can see the changes in the midbrain region. So around that, that is, you can differentiate, but I don't know much about other than maybe in the CSF, if you see amyloid beta, normally these pathologies are always coexist mostly there. I don't see any pure form, but that sometimes if you can detect alpha-synuclein something, the level, then there may be, you can differentiate, but we need to work on a lot.
Right. Alpha-synuclein is more associated with Parkinson's and Lewy body.
And
So
the
that
Lewy
could
body
be a
dementia.
possible. Yeah. Great. Thank you for answering that. And again, anonymous attendee, you can email us at publications@alzheimer.ca. All our other questions here will be answered by email in the coming week. We're going to wrap up now. Thank you all so much for joining, for attending, for all your questions and your lived experience sharing and comments. Join us next time, February 14th, Valentine's Day at 12 Eastern, when we will talk about diversity and dementia in Canada. More information on that talk and registration link right now at alzheimer.ca/febtalk. Thanks again so much for joining, everybody. Have a great day. Thanks to Brain Canada Foundation for continued partnering on this event. And let's keep on learning together. Have a great day. Thank you all.